This is the third in a series of videos about rationalizing the denominator. Today we'll be looking at rationalizing denominator of an expression for which its denominator is a binomial. Okay, so binomial, that means that you're adding two terms here. So 2 minus root 3x. And first thing you want to do is you want to see if you can simplify anything from the expression itself, like anything with a radical inside the radical or not. Nothing can be done here though. So once you establish that, you're going to go ahead and multiply by the conjugate. And the conjugate is simply the two terms that make up the binomial, but the middle term is now changed from minus to a plus. If it was plus, it would be minus. And we have to do that to both the numerator and denominator, because if you just did it to the denominator, it would change everything. Okay, it changes the problem, and you don't want to do that. Rewriting the denominator, you have what we call a difference of squares. So think of this as a minus b, it's like a plus b. So basically you have two binomials, and when you multiply those two and they're conjugates of each other, a minus b times a plus b, this equals a squared minus b squared. Okay, and essentially, yeah, it's like you have the same thing in both expressions. The term in the middle is different. And if you multiply those together, that is equal to the square of the first part minus the square of the second. You could simplify that out by foiling as well. I don't recommend it though, because it takes a bit of a time. So the way that formula would work for us, a is 2. So you would have, the result would be a would be 2 squared, and then b would be the square root of 3x. Okay. So again, instead of foiling, you can go ahead and do what I just did here. And on the top, leave that. And if I simplify a little further down here, let me just move this problem down just a bit here. And you would, for the denominator, 2 squared is 4 minus 3x. And if I distribute the 5x, now some people will tell you, some teachers will say, you could just leave it. If you're asked to distribute, I'll just assume that for a sec, but again, you might not need to. 5x times 2 is 10x, and then 5x times root 3x is as is. Yeah, a lot of people will say it's equal to 15x squared. No, it's not, because I can't apply that reasoning because the 5x doesn't have a radical in it. If it did have a radical, then you can say that, but we do not. And that is how this works in this instance. Now, let me move to my problem that I have down here. So same idea, I want to rationalize the denominator, but if you noticed here, I can actually simplify this a bit before we begin. The square root of 50 is, you can rewrite that as 25 times 2, and 25 is 5, and you would have a 2x here, and then 1x can come out of here. Yeah, that's like saying x squared times x, and you would have 1x left in there. Okay. And now this has been simplified, so I can go ahead and rationalize the denominator. So I would multiply by 5 root 2x plus x root 3x on both the numerator and denominator. And I'm just looking at the denominator here for a second. We'll go back and look at the numerator. Again, this is a difference of squares. It's going to be 5 root 2x squared minus x root 3x squared. And you would have 25 times 2x minus x times 3x squared. So it'd be 50x minus 3x cubed. And then, yeah, for the top, Yeah, the top we don't care too much about. Sorry to hurt your feelings, numerator, but we're more interested in the denominator. So you would get 95x square root of 2x plus 19x squared square root of 3x, and that's about it. You can't simplify that expression any further, and that's what I would have. And it doesn't look nice, but it is what it is. All right, so that's how you handle rational denominator with something with a binomial, with a square root. And we really just work with square roots. We don't really work with cubics or anything like that because it's a more challenging. All right, well, I hope this helps. Thank you so much.